This is an example of a binary tree. First thing I'm going to do is create a binary tree class. So for my binary tree, we'll be passing values to this binary tree to build our tree. So the types of objects that I want to be passing to this binary tree will extend or implement the comparable interface. So I want to create a generic Next thing I'm going to do is create my entities that will be contained within my binary tree. So you basically are going to have a data element, and you're going to have a left and right element, which are binary trees within themselves. Since I declared those values private, I'm going to have to create the constructor and getter methods that will allow me access to those particular entities. So first, let me create the constructor. So when I create my binary tree, this is what I'm going to be utilizing. So the only thing I'm passing to my binary tree in the construction is the data. I'm going to be initializing data. I'm not going to be initializing left or right nodes. Now, I'm going to be creating my getter methods. So initially, after creating binary tree, I want to be able to do inserts into my tree. So I'm going to create an insert method. Insert val will be the value that I'm passing to create a new I'm passing the insert into my binary tree structure. And basically it's going to create a new binary tree. So the reason why I wanted my object that I'm going to be passing to my binary tree to implement the comparable interface is because I want to utilize the Compareto method. So basically the Compareto method allows you to compare two similar objects, and if the object is lower, if the object that you're comparing to is lower than the object to the other object, then it returns a -1. If it's equal, it returns a 0. If it's above, it returns a 1. So if it returns a -1, I want to insert into my left node. But first thing I'm going to do is check to see if the left node is already occupied. So if the left is not occupied, then create a new binary tree. But if the left node is occupied, I want to call this function again on the left node. The left node is a binary tree within itself, so left is going to have the insert method. It's going to recursively call that function to insert until it finds an empty left node, or it's going to call this recursive function to check to see to add to an empty node that could be left or right, but it's going to be within that existing binary structure that's underneath the main one. So it's going to call this function until it finds an empty node. And I do the same for the right. So, just copy this. So if the value is above 0, then I'm going to do the same for right. Oops. So that concludes the insert function. So basically, as you see here, checking to see if first within the node that you're in, it's going to check to see if left is null. Before inserting, it's going to check if left is null, it creates a new value, or it does a recursive call. It calls the insert of that left or right node and checks to see. So it calls it recursively. So that node will call the same function until it finds something that's empty so that it can work with. Alright, so the next method I'm going to create is the search. Let's see, make sure I make the right. So my search will return a Boolean value, which is a true or false value, if based on whether that value exists or doesn't exist. So passing a search value. First thing I'm going to do is check the current node. If data equals search, return true. So I'm checking the current node. So if the current node doesn't contain that value, now I'm going to search either left or right to see if that value is within my binary tree using the same method, the Compareto method. So I'm checking. If it's less than 0, I know, all right, search left. I'm doing a recursive function. I'm doing a recursive call of the search function also. So I'm going to say return. This return is going to return a Boolean. Now if left is not equal to null, left is not equal to null, and I'm doing a recursive search. So this search file can return true or false. So if I'm searching left, if it decides to search left, if left is equal to null, then it's going to return false. Or either it's going to it's going to call this search recursively and repeat this search function and check that value. So now I'm going to, but if it's above the search value, then it's going to go right. So, and I'm going to repeat the okay. All right, so that concludes our this should conclude the binary tree class. So next thing we're going to do is test. Let me see, something on here is wrong. Let's see. Got an extra closing bracket here. Let's see. Delete. All right, so next thing I want to do, I want to test. I want to test my binary tree. I want to test my binary tree. So create a new class. Create a new binary tree. Integer. So integer extends, it implements the comparable interface. I'm going to create a new binary tree. Root, give it an initial value of 10. Give my binary tree initial value of 10. I'm going to then add values to my root my new object, which has an initial data value of 10. So I can insert new value. If I insert 15, that should go right. If I insert 20, that should go right. 15. Should go left because it's less than 10. All right, so let's see how this, let's see, I'm saying, first thing I want to do is check my search. Now that I have entered new values in here, I've entered values in, I want to search, let me see output. So I'm doing output, it's going to return a true or false value, Boolean value. So I want output, and this is a test. See if this works. All right. So let's see. Test my. I want to test. Run as Java application. Save. Returns true. So I did a search for 15. Now if I search for 21. See what it returns. Run test tree. First test true, second test false. So that worked. So the values that I entered in here will return true. Now now if I do another search, on the left side. Let's see. Let me see. Why is my search not working? Let's go back. So in checking my binary tree search, I found what the error was. So in my Compareto method, in my search, in the Compareto, I'm comparing it with the search val. So that's wrong. It should be I should be comparing the search value with data, which is the current data element. of the object that I'm searching, the data element. The new search value should be compared to the data element. So I'm going to save this, and let me test this again. Let me run this test. I'm going to run my test tree, and now that's true. So another way I can test is I created these getter methods. So I know based off of my inserts, it should return a value. So let me see. System. Oops. Okay. Let's see. So I'm going to use my root object. I know I have two left objects. Get left. Get left. Get data. This should return a 3. Let's see what's going to happen. We're looking down here. I'm going to run this, file, save. I don't know what that is. You run this, and yep, it contains my 3. So if I try to do another get left, which doesn't exist, if I try to do another get left, I should return an error or null. Left. Let's see what happens, because there shouldn't be another left here. Save it. So it returned a null because there shouldn't be another left. So that concludes the binary tree data structure and coding test. This is like a standard coding test, especially if you're applying to a position like Amazon or Google. They throw this type of coding test. I got this test at a big financial firm. This was one of the tests, a binary tree. So depending on how advanced the Java position is, so it's not only Java, but it could be even Python or C. But depending on how advanced the position is, they're going to throw this sort of test at you. And with that, I say peace.